Okay, welcome back. This is Maths Part 2. We're looking today at using our knowledge of fractions and estimation to give approximate areas of irregular shapes today. So, with that in mind, looking at our first slide, we have got a pond in our diagram, and each square is representing 1 metre squared. So, Ron's answer is 4 whole squares and 11 parts for this area. Is that an acceptable answer? What does approximate mean? What does approximate mean? Yes.
Like a sensible answer of around what it might be.
Yeah, a roundabout, isn't it?
Yeah,
A roundabout. Yeah. A little bit different to estimation. Okay, so approximate is thereabouts. Okay, whereas an estimation is what you think it might be. Okay, a sensible guess. Okay. Would you like to contribute?
It's like a guess.
A guess? Yeah, like a guess. Okay, so what do you think would be an acceptable answer? Well, we're taking a look at it. We've got how many whole squares can you see that are coloured in blue? So that's where I would start with this one. Yeah?
4.
4 whole squares. Okay. Then we've got some that are almost whole squares, haven't we? And then we've got some that are very much parts of squares. That's why I use the word fractions in our learning objective. Okay, so thinking about how many parts then are not whole, but the parts then could be put together to thereabouts make equivalent to 1 whole. Okay, so when you've got questions like this, you're going to be trying to use those wholes and those parts. Okay, let's take a look at this next slide. We've got 3 different colours. We've got a grey pond, a green pond and a red pond this time. Okay, so each square is representing 1 centimetre in length and width. So it's 1 centimetre squared for each one. Which shape has the greatest area? Look closely at this. What do you think? What do you think? Yeah?
I think the grey one's got the greatest area because, as it says, it's 1 centimetre in each box. The greys covers more squares than the green and blue, so therefore the grey is the bigger one.
Yeah, absolutely. So, well, quite rightly said, there are more squares in this grey one than there are in the green and the, did you call it blue? It was red or pink. Okay, so there are definitely more squares in here, so I would say that that one is. Which ones were about the same, do you think? What's the same about each image? What's different about the image? Yeah?
That all the squares are a bit different than each other.
So they are different, the squares are, in this representation they are different sizes, but what does it tell you that they are the same?
The size.
Yeah, well done. So it specifies the size here. Each one is 1 centimetre, but they are different in the way that they have been represented. Well done. Okay, so let's take a look at our next slide. Now, we talked about approximation, didn't we? So here we've got a pond demonstrated here. I've drawn my own pond over here. So if I was going to sit and work out approximately how would I go about this? Well, I would take a look at and think about how many whole squares have I got. And I would see and look, well actually I've got some nice whole squares all the way along here, so I could dot all my whole squares. Not quite. So as I'm doing so, you can see I'm working my way around my pond. And then can fill in all of the centre. So with those, I can add up all of those dots as my whole squares. Would you like to do that? Add your nice close to the front. While she's doing that, we're going to be looking at then these part squares. So you'll be looking then and thinking about, well, maybe if we've got some 2 halves, they can make 1 whole. We've got some parts that are almost some little parts as well. So like, for example, this little part would maybe match with that one, which will make another whole. How many did you have? 55. So we've got 55 whole squares. And then we can start adding up, and that one will be another 1. That one and that one would make another 1. So you can keep on going around your square and then total it. You've got this one maybe, and this one that would make another hole. This one and this tiny bit would make another hole. This one and this tiny bit would make another hole. This one's almost a hole anyway in itself. That one's almost another hole in itself. That's number 2. And then that one and that one together make another 2. So 55, 1, 2, 3, 4, 5, that's 60, 1, 2, 3, 4. So I think about 63 centimetres squared would be my area for my pond here. I'm working in centimetres here. This question, remember, is looking at metres squared. Okay. If I then, for my task, had the question of having to draw a shape, an irregular shape with a certain area, how would I go about that? That's our next task we're just going to run through. So, for example, here it's asking me, can you draw an area, for example, of an island that has got at least 8 squares? Put a dot in the middle. So, if I was going to draw my pond with 8, I could then go 1, 6, 7, 8. At least 8. Then I would then draw my pond around the outside of that shape. It's approximately 8 centimetres squared. Okay, so that is the area. So that was the technique that I would have first of all, is putting the dots in first before you draw your outline, rather than drawing an outline and realising that you haven't got enough space. Okay, there's one further slide here which introduces the idea of the last Chili challenge, and especially when we're looking at the plenary. This is where you have to think about how you can represent different areas within the space. So, for example, this is a whole island this time, and you're looking at different features such as a play area, a picnic area, and a sandpit. So again, using the technique I've just used within your large area, you can again do some dots for you to map out where those squares would be for those different areas. Okay, so you're now going to begin your Chili challenges for this follow-up now, and I'll see you later. Thank you.